Hello, and welcome to Astronomy 100. In this video, we're going to continue our discussion of galaxies. And in the previous two videos, we've started our discussion about the general overview of the Milky Way galaxy itself. A couple of the big questions that we've answered already is we now know the shape of our galaxy, we now know the size of our galaxy, we now know our location in our galaxy. But one of the questions that, of course, came from that has to do with why the shape of our galaxy happens to be what it is. So let's go ahead and jump back into things here. In this screen here, you can see this is the illustration of what the Milky Way galaxy would look like from the outside. This is the top-down view. If you were hovering over the Milky Way looking down onto it, you would see this particular shape. And a couple of things that I'll remind you of that are important is remember that our galaxy officially is a barred spiral galaxy. The spiral is obvious that you see here in the picture, and the bar has to do with the fact that some of the spiral arms seem to originate on the ends of this bar-shaped structure. And again, this is not a solid thing. This is just a collection of stars and gas and dust at the center of the galaxy that has been shaped into this bar that you see here. And the arms of our galaxy have been mapped out. We have names for each of the arms, and this is showing the location of the sun in our galaxy. We are at about 28,000 light years away from the center of the galaxy. We're not at the edge, we're not at the middle, we're about 2/3 out from the center of the galaxy. The galaxy is about 100,000 light years all the way across, and it's got a galactic nucleus, it has a galactic disk, and then of course the halo. Now, towards the end of the last video, we introduced the idea of why spiral arms. And so the spiral arms of this type of galaxy has been a bit of a mystery and a little bit of a controversy over the years that we have, of course, put an effort in to try to understand that. An easy way to think of the spiral arms is that the arms themselves might have something to do with the speeds of the stars. What we do know for sure is that stars that are moving through the galaxy, they're moving around like this, as I'm showing with the cursor, and they all move at various speeds. Some of the stars move faster, and some of the stars move slower. Now, this should be something obvious, or this should be something that makes sense, because earlier in the semester we talked about Kepler's laws. And Kepler's laws have to do with the period of time that it takes a body to orbit around another body based on the distance to the body. And what we discovered through Kepler's laws is that we should expect that stars further out should take much longer to move around the galaxy's center than stars that are closer in. It has to do with their speed, it has to do with their distance. The problem, though, is that when we measure the speeds of the stars in the Milky Way galaxy, we find that they don't actually follow Kepler's laws as we would expect. Now, there's a reason for that that we'll explore in another video, but the movements of stars are not quite what we would simply assume. Now, here's another problem. Let's try to draw an illustration to get an idea that's related to spiral arms, try to make it more obvious here. Let's say that we had 4 different stars, and each of these stars, lettered A, B, C, and D, are going to move around in the circle that you see here. So essentially the orbits of each of these stars shown for you in this drawing. Now, if star A moves the fastest, and then star B moves slower, and then star C moves yet slower, and D is the slowest, when we essentially say go and let them start to move, what would of course happen is their different speeds would trace out what we would expect to be a spiral shape. And so what you'll notice is the previous line of stars would actually have, let me go back for a second. So the previous lining up of the stars, based on their different speeds, would no longer line up. And you can make the argument that, of course, this makes a really nice spiral arm. A is here, B is here, C is here, and D is here. The problem with it simply being a matter of speed is that as time goes by, what would happen is the spiral shape that you see here would wind up. In other words, it would wind up so tightly that the galaxy would no longer have the spiral shape. It would be a temporary thing. And what we know is that galaxies are very old. They are essentially as old as the universe is itself, or pretty darn close to it. And so when we look at galaxies in our universe, we shouldn't expect to see spiral galaxies at all. They should all be wound up. So it cannot simply be the speed of the stars being different at different distances to create the spiral arms. So an alternative idea was suggested that seems to be the correct explanation, and this one is called the spiral density wave model. Now, to show you this idea, I'm going to use an analogy here in this picture, but let's start off with it's really the consequences of gravity and the idea of density. Now remember, the word density is referring to how tightly packed together something is. So when something is very dense, its material is very tightly packed together, and when something is not very dense, its material is spread out. An example is the density of metal is much higher than the density of air. And so the density of something has to do with how tightly or loosely the material is packed. Now, here's the idea. If you think about a busy highway, two-lane highway here, let's say 2 lanes in one direction, if you have a slow-moving truck, let's say that's going down the fast lane here, what happens is it creates sort of a barrier, a moving barrier, but a barrier that all the other cars have a hard time having the ability to go around. So you have cars starting to bunch up as they're trying to go past the slow-moving truck. And so you have lots and lots of cars going by, but then there's a little bit of chaos as they're slowly taking their time, one by one, trying to work around the moving truck. What I'm going to do is actually animate this to give you the idea. So, and it'll repeat over and over again. So here comes the semi, and you can see here are all the cars that are trying to go past it. So essentially all the cars are moving to the fast lane, speeding up to go around it, and then continuing on their way. So as long as the truck moves at a constant speed and the cars move at a constant speed, but their speed is faster, what you'll notice is they have to bunch up as they are working their way around the slower moving truck. So the idea is, let me switch to a picture here. The idea is that in a galaxy, what we have is a very slow moving density wave. And that density wave is essentially created due to gravity. And this very slow moving density wave working its way around the galaxy, of course, is going to ultimately lead to the spiral shape. And I'll tell you more about that in just a minute. Here is an example. This is the galaxy called M51, and this is nicknamed the Whirlpool Galaxy. This is yet again a top-down view. The Milky Way galaxy would be very similar in shape. Notice the beautiful spiral arms coming out from the center of the galaxy. Now, if we were to look at some of the details, for instance, there are some clues. What you'll notice is along the spiral arm, you get a high concentration of star-forming regions. These are places where stars are actively forming. And just 2 examples are shown here. These are actually 2 examples from our galaxy. But an example is if you could look at this part right here through a big telescope, it would look like this, and this one right here would look like this. So notice the pink glow of all of these star-forming regions. Now notice the star-forming regions are only along the spiral arm. Really not a whole lot of anything in between. No star-forming regions in between. If you remember from a previous video, star formation requires a concentration of gravity. So these star-forming regions show us where gravity is most concentrated to make it so the force of gravity can trigger the formation of stars by collapsing these clouds. So it is as if these star-forming regions are tracing out the density wave that is working its way around the galaxy. So let's kind of put all this together here. What happens is we have all of the stars of our galaxy moving around. we have all of the clouds of gas in our galaxy also moving around the galaxy. And so what happens is the stars are like the automobiles in that animation I showed you. They're moving around the galaxy at a faster speed than the density wave. The density wave is like the big semi-truck moving slower. So as the density wave slowly works its way, constantly moving around the galaxy, you have these big clouds of gas that are moving faster, like the stars are moving faster. And what will happen is the clouds of gas will push through the density wave as if they're trying to move around the semi. And as these automobiles moving around the semi, the gas clouds move past and through the density waves. But in the density wave, gravity starts to squeeze the clouds. So you have a cloud becomes squeezed as it moves through the density wave, and then as it leaves the density wave, it starts to spread out again. But as the clouds get squeezed, and that process starts to trigger the formation of stars. So these clouds moving in and out of the density wave will have star formation start to rapidly happen as they move through the density wave. Now, the last piece of the puzzle is, in many of these star-forming clouds, you get the formation of very massive stars. And the very massive stars tend to be very blue-white in color. And what will also happen is, remember from a previous video, that the high-mass stars live very short lives. And so what will happen is a cloud moves through the density wave, it creates high mass stars, they glow and they shine very brightly for a number of years, but then they essentially die by the time the cloud leaves the density wave. So the consequences of this is these high mass, very luminous stars are going to trace out what appears to be a spiral arm pattern. So the density wave, as moving around the galaxy, and the interaction of the clouds and starting to form stars as they go through these density waves, are going to give the illusion that it's a spiral arm pattern. The bottom line is the spiral pattern is a bit of an illusion. It is not stars moving at different speeds. It's the formation and quick lives and deaths of stars as they move through these density waves, creating the appearance of the spiral arms. So what we now know is it's a bit more complicated, but it has to do, once again, with the idea of gravity. Now, is there some evidence for this? Let's take a look at a picture here. This is a galaxy nearby. This is M33. It's referred to as the Triangulum galaxy. It's a perfect example of this. You'll notice that you can actually see lots and lots of pink clouds, and you can also see lots and lots of blue stars. So the blue stars are what we call hot O and B type stars. These are spectral types, spectral type O, spectral type B. Notice that you get lots and lots of hot stars that are right along the spiral arms that you see here. And then you also see lots and lots of these star-forming regions, these excited hydrogen clouds. And you can see that it is only along the spiral arms that you really get these very hot O and B type stars that live very short lives. So as these clouds move through the density wave, they compress, stars form, they live, they die, and then the cloud continues until it hits the next density wave, creating the next generation of stars. So it's essentially that these spiral galaxies are being forced to have this spiral appearance based on how gravity interacts with all of these individual things inside of this galaxy, creating what's called a density wave. Now, the last piece of the puzzle is, the last question is, what causes the density wave? What would force this gravitational resonance or this density wave to happen? And what we think is, the answer is the interactions of galaxies. What we now know is that galaxies will interact with each other. So here's a group of 5 galaxies that are gravitationally pulling on each other. And the gravitational pull of each of these galaxies on its neighboring galaxies can force this gravitational wave or this gravitational density wave to start to work its way through the galaxy. So it's an interaction between the galaxies themselves. Now, In the next video, what we're going to talk about is what's called galaxy morphology, which means the different shapes of all the galaxies in our universe. There's a variety of shapes, and we'll see how we can start to divide them into different categories. But we're just about out of time, so we'll save that for the next video. We'll see you then.